right, this is a quick recap of the Pythagorean theorem. I'm going to start by letting you know that the Pythagorean theorem, the equation looks like this. It's a squared plus b squared equals c squared. And this equation applies to right triangles. So right triangles is a triangle that has an angle with the measure of 90 degrees. And this little square symbol here tells you that that measure is 90 degrees. On a right triangle, we have two legs, excuse me, and the side that is directly across from the 90-degree angle is called the hypotenuse. Each leg, we can label them A and B. We can also reverse that, so the bottom side could be B and the top, the standing up side can be A. But the hypotenuse will always be C. So we've got A, B, and C, and that's where we come up with A squared plus B squared equals C squared. Okay, the Pythagorean theorem is used to find the measure of a missing side. So let me start with this, this triangle here. It's going to be a quick 5-minute recap of the Pythagorean theorem. Let's start by, I'm going to start by letting you know the equation for the Pythagorean theorem is, pen's not working, a squared plus b squared equals c squared. This equation is used only with right triangles. Right triangles are triangles that have a measure, one angle with the measure of 90 degrees. This little symbol here tells you that this angle is a 90-degree angle, and that is what a right triangle is. It has one angle of 90 degrees. In a right triangle, we've got two legs. The sides are called legs. There's one leg here and one leg here. And then the side that's directly across from the right angle is called our hypotenuse. And when you label the hypotenuse, you will always label it C. When you label the legs, you can label them A and B, or you can switch these around and you can make this one A and this one B. It doesn't matter. Each leg, the legs are just labeled A and B. All right, so when we have a missing side, that's when we will use the Pythagorean theorem. So let's take a look at this triangle. This triangle is missing the measure of C, the hypotenuse. Okay, so this is a great example of when you should use just the regular equation, a squared plus b squared equals c squared. And what you do then, I'm going to say that this side is A, this side is B. I know that it is a 90-degree angle and that these are my legs, this one and this one. So what I'm going to do is fill in my variables, fill in what I know. I know that A is 4, I have to square it. And I know that B is 9, and I have to square it. And this is when we have C all by itself on the other side of the equal sign is perfect for when you are missing the hypotenuse, because at the end, your answer will read C is equal to some number. So 4 squared is 16, and I know that 9 squared is 81, and that equals C squared. You're adding these together, and this is going to equal 97 is equal to C squared. Now, we don't want to know what C squared is. We want to know what C is. So in order to get rid of the little exponent, the inverse of squaring something is taking the square root. So if you take the square root, it leaves you with just C. But what you do to one side, you have to do to the other side. So you take the square root of 97. And sometimes you can leave it as the square root of 97. Sometimes you can give the answer, the decimal answer, which in this case will be 9.85. One thing to remember when we're talking about the right triangles is that your hypotenuse should always be your longest side. And in this case, it is our longest side, so that works out. Now, I do want to show you something else. When you're missing the hypotenuse, you're going to use your regular Pythagorean theorem, okay? When you are missing either leg, you're going to change around your equation a little bit so that it looks like this, so that your A will be all by itself on the one side when you're missing A as a leg, or that your B will be all by itself on the one side of the equal sign when you're missing that side B. So let me show you an example of that. Let's see, that's a hypotenuse. Okay, so this equation here, this triangle here is missing one of its legs. So what I'm going to do is I'm going to label my legs. So I'm going to say that this is A and this is B. I know that this is my hypotenuse, or C, because it's directly across from that right angle. So the equation that I'm going to use here is, since I'm missing A, it's going to be A squared is equal to C squared minus B squared. And so what I'll do is I'll fill in what I know. And C squared is 11. Well, C is 11. And B is 6. Keep working down. This is going to be 121 minus 36. So I know I just take 121 and I subtract 36. And that gives me 85. So A squared is equal to 85. Now, in order to get rid of the little exponent, I'm going to take the square root. I'm going to take the square root. And then A is going to equal the square root of 85. And if I plug that into a calculator, that's going to give me 9. A is equal to 9.22. And 9.22, and now I see that my hypotenuse is bigger than the other two legs. All right, so I hope this was a good recap for you, and look out for more videos.